Hello everyone, my name is Conor Schmidt, and I would like to start our session with the main question. What if you could learn tips and tricks for a successful career in power engineering? Advices from a senior engineer that can boost your career and bring value to it. Moreover, as students and young professionals, advice that can give us a direction to build our path into a successful professional life. Our guest speaker, Dr. Srijib Mukherjee, comes with 30 years of research, engineering, academic, and management experience in power systems operation, transmission planning, engineer energy markets, electrical grid resilience, and distributed generation of power systems. He's a licensed professional engineer PE in 3 different states, as well as a license to operate the US grid as a NERC certificate system operator. Beyond that, he has mentored, advised, and chaired 10 PhDs and master students' theses. As well, he has been a joint faculty at the University of Tennessee and Oak Ridge National Laboratory. So thank you very much, Dr. Sirjip. It's like a pleasure to have you here today as a guest speaker and sharing a little bit of your experience doing all your journey as a successful power engineer professional. So before we start, I just would like to remember all the attendees that we have chat, we have Q&A. So during the presentation, just drop your questions there, that we are going to have a special moment to assign these questions for the speaker. You also are able to unmute yourself. So if you'd like to make a voice question, you just raise your hand and you are going to unmute yourself. So you can just speak and we can have like a interaction with all people here, okay? Thank you very much, and the floor is yours.
Thank you, Conrad, and thank you, Asala. Thank you for your time and for allowing me to share some of my experiences in my long career. And I hope I can convince some young minds over here um, to go into the field of electrical power engineering. So yeah, like Conrad said, I work in the Electrification and Energy Infrastructure Division at Oak Ridge National Lab. It's a federal national lab. In fact, it's historically known as the lab that had the Manhattan Project, in which the atomic bomb was built in the 1940s. And so it is a very well-reputed lab. We have 17 sister labs, including NASA and Jet Propulsion Labs. So we work collaboratively on many, many efforts. So that said, let me go to the next slide. And I don't want to go into these lengthy discussions of what an electrical engineer is or a power engineer is, but I sort of give an overview and then I open it up for discussion and for conversation as to knowing the nuances. People often forget, it's like calling a Scotchman an Englishman. So power engineering is literally, electrical power engineering is a subfield of electrical engineering, right? So we engineers would know that electrical engineering comes as being, you can be electronics, you can do digital computers, you can do power engineering, you can do telecommunications, you can do control systems, you can do radio frequency engineering, you can do signal processing, you can do instrumentation, you can do microelectronics. So there are many, many different areas, but power engineering involves as a subfield that deals primarily with the concepts of Michael Faraday, who in the early 1500s, I believe, it could be earlier, that actually discovered that if you applied voltage to a device, it can be converted to a magnetic field via induction. And that's what created things such as a generator and things such as a transformer. So those became devices through which power engineering came through. So you can see over here in a broadened sense that electrical power engineering deals with power. So power, of course, is different from energy. Okay, so engineers, if you look at power, when you look at power, it's it's just power, which is volts times amps, and that's what power is. But when you take that over time, it becomes energy, right? And now if I look at the broadened sense of what energy is to a person that's not an engineer, then energy can be physical energy, chemical energy, water energy. It can be holistically looked at other forms of energy. So energy comes in many forms, but from physics, the word energy is really, you could have energy in motion, which is kinetic energy, or energy that's stagnant, and that's potential energy. And then if you take power and deliver it over time, then that becomes energy. So power engineers mainly deal in the broadened sense. The old days used to deal with generation, transmission, and distribution. And we're all familiar with the AC grid. But historically, what was created in the original days was the DC grid. So that was Thomas Edison's first ring DC high voltage lossless grid. So we went from Edison to a guy called Tesla, who had an alternative power, a full signal that went positive and negative from 0 to 180 degrees. And that created AC power. And the distribution of AC power was done to interface it to more usable appliances and devices that could be used. The problem with DC power, even though it can be transferred without any losses, was due to voltage. It was unusable at certain levels for certain equipment. And looks like we went from DC to AC, and now we're going back to DC in many of our applications of what the future might hold. So when you think about power engineers, you're thinking about not only just generation transmission of electricity, you're also thinking about control systems and how they interface. It also goes into advanced transportation. It also goes not only just grid management activities, it also goes into buildings management and energy efficiency products. And it goes into renewables and renewables engineering. And power engineers play a critical role in renewables when it comes to solar, wind, and geothermal applications. So let me go to the next slide. And this is the IEEE definition of what I'm not going to read through these, but you can get a picture what a power engineer does. So they develop, in the old days, we developed large networks for the power grid. Power engineers, they design and work with generators, transformers, circuit breakers, relays, transmission lines, and they connect those power systems to electrical substations, which move from one high voltage to the other. And then some power engineers work on off-grid networks that generate electricity. We're talking about dispersed generation these days. We're talking about microgrids and off-grid applications. And we're talking about peer-to-peer sharing of energy that we could be looking at applications such as blockchain. So power engineers, we're really in a glorious time. The mother of electrical engineering is power engineering. Literally, that's where it all started. So power engineers also deal with things such as motors, batteries, capacitors, inductors. They also deal with other energy storage devices that are coming in, compressed air devices, flywheels and batteries, and other energy storage applications. Hydro or pumped hydro, for instance, is an energy storage renewable. So you can have those kind of applications for each one of them. So power conversion is a big part of being a power engineer. The U.S. Bureau of, the Bureau of Labor Statistics, you can see you could go into manufacturing, you could go into testing, you could go into construction, you could go into installation, you could do systems engineering, and you can do applied research. So the good news about electrical power engineers and electrical engineers in general is that we are not in the pure sciences, but we are in the applied sciences. And the difference is that you work on products and systems that you can apply to the real world. You're not sitting discovering an element on the periodic table. So there's a clear difference in doing that. Now, an electrical engineer is not an IT person, somebody who does Python coding and or writes code here and that and this and that. Your concepts have to be sound. An electrical engineer goes through a pretty math intensive bachelor's or undergraduate degree that encompasses things such as the circuit analysis, electromagnetic devices, rotating machines, T&D, power system protection, generation, general power engineering for economic analysis, codes and standards, and then power electronics and devices, which have now become more and more critical with sensors and actuators and things like that you see on EVs and other electrical cars for a smart grid, where you'd work with Internet of Things. So it's a very broadened field to what you might consider. So where do electrical engineers work? So there are many varied opportunities, right? But typically electrical engineers, the BLS, which is the US Bureau of Labor Statistics, say the median salary is about 100K. And young engineers coming out with a bachelor's degree would make somewhere around $60,000 with an electrical engineering or an electrical power engineering degree. Of course, that value goes significantly up if you have a master's or a PhD degree, and even actually nationally get licensed as an engineer, what we in the US call a professional engineer or PE. So you would have to take the engineering intern test through NCEES to Clemson University, and then actually go through a professional engineering licensing exam after 4 years of getting your engineering internship test. But now you can actually do both tests together, but get fully licensed within 4 years, which enhances your credibility. In Canada, that same application, I think, is called Chartered Engineer or C Engineering. So when you put the C Engineering behind your title, along with your bachelor's degree or your master's degree or your PhD, your credibility goes threefold up because you're recognized as a very credible electrical power engineer. So that was that. So it's literally the 6th best profession in the US, and the demand is off the roof because if you realize what the new energy secretary, Jennifer Granholm, what she said, we are moving to a zero carbon future, and electrical power engineering plays a critical part to that zero carbon future. If you look at what happened in Texas, and Conrad is from Texas, in the middle of February when we had the massive blackout and people lost electrical power. There are many factors. It is wrong to say, just because wind farms and solar farms went off. It was a combination of many factors. Why? The US electrical grid is separated into 3 interconnections: the Eastern Interconnect, the Western Interconnect, and what we call the ERCOT, or the Electric Reliability Council of Texas. So the Eastern and Western interconnect in the United States are synchronously connected. That means they operate under one frequency. And the ERCOT interconnection with the ERCOT, the Eastern Interconnect and Western Interconnect, operates asynchronously. So ERCOT is an independent grid, and therefore importing power and not having transmission infrastructure to actually bring it in became a problem. Several other problems are coming in because of greenhouse gases and therefore retiring coal plants and putting in more renewables, wind and solar. But the wind doesn't blow all night long. and or all day long, or the sun doesn't shine all day long. So how are you going to regulate to maintain the nonlinearity of the grid? So there are many complications that one could look at. I want to show a small YouTube video for 10 minutes, and then I'll open it up for questions, okay? So just take a look at this, and this gives you a good idea of what electrical engineering.
Dr.
So,
Srijib, it might be, I don't know if, do you have like audio on this YouTube?
I do have audio on this.
So the, WebEx might have an issue with that, right, Conrad? Or did you like figure out, we can test it, but is there anything you can,
There
we
is
can test it?
Mhm.
Because it's not like Zoom. So this, the WebEx has like had trouble when we play video, but let's go ahead and check if it works. If it's working, it will be awesome.
Okay.
Yeah,
Let me give
basically,
it a shot.
when you go to share your screen, you need to just check one checkbox. I don't know if you checked that box before, but we can try, and if it doesn't work, we can just figure out. Okay.
Can you hear it on your end?
No.
No.
We cannot, right?
We cannot see it too. So let me copy it. Yeah. So
maybe if you just drop the link in the chat, we can try to open it here as
I
well.
can do that. I can do that. I can copy the link over and copy. Let me just stop the video. Just a second. I am so sorry. Let me get out of here and put it into the chat.
So while Conrad, while you're figuring it out, I might have a question or two for you, sir. Would it be okay for you?
Please.
Yes.
Please.
So I have been following you. So I'm a big fan. So kind of, I know a few things about you. So the first thing that comes to my mind is that you were certified to operate the grid in Florida. Like, were you an operator? Did you have the NUC certification at some point? How did that come about?
Oh, that's a great question. So when I was in grad school, like you, Asalam, I started as a summer intern with Florida Power and Light, and I was assigned to the Grid Control Center. And eventually, when I became a young engineer at Nevada Power Company, I was assigned as the grid engineer responsible for teaching new grid operators to operate the grid. That means what they call dispatchers, and in generation operator, a transmission operator, and a distribution operator. Now, the only way one can get credibility to teach such a course was you yourself have to do it. So coming out of college or grad school, I didn't have much field experience. So, and experience with the grid operators who ran through the ranks of being linemen and substation maintenance workers and things like that, and nuclear plant operators, Navy nuclear plant, Navy and Army and the Marine Corps who've actually gone through those kind of programs and had several years of experience ahead of me. So I spent 6 months as a generation operator to understand how the grid operates, especially the Western grid and the Western interconnection. And in 1996, when deregulation came around, actually got implemented in 1998, 1999 with FERC FERC 991, 1999 with the OASIS, Open Access Same Time Information System, and FERC 2000 came around. They required anyone operating the electric grid to be NERC certified. So we had to be NERC electric certified to even converse at a competent level on how the grid operates. And this is in terms of system operations. So whether it be generation operations and automatic generation control, or it be SCADA and transmission switching. So transmission switching, we had transmission one, and now we're going into distribution level and how would you switch in a device or switch out a device, which is a tremendous amount of safety, a tremendous amount of responsibility, and you need to be certified. For example, why do we tell engineers to get licensed? The reason we tell them is to maintain a standard. Like you go to a medical doctor and the doctor is an MD, and that's fine. But you do want to have the doctor to be board licensed to meet a national level. Like, for example, when you hire a lawyer, you don't want to hire a lawyer that hasn't passed the bar exam. So how would that be? Same thing when somebody wants to hire anybody can claim to be an engineer. You have this title of engineer randomly used with people who don't even have an engineering degree, and they give them random titles. So what is your standard of actually being an engineer? The law requires you to only hold the title of engineer once you've passed the PE exam in the US. Many people don't know that, but you have to pass the national NCES exam from your university, which is run by your University of Clemson, and nationally pass that to be qualified as an electrical engineer. Same thing with civil, which deals with infrastructure and services and other forms too. So chemical engineering and other forms, also mechanical has the same thing. Yep. I hope I answered your question with that.
You did. Thank you. It's very interesting. Conrad, are you ready?
Yes, just give me a second here. Okay.
Yeah, you don't have to go up to all the way to the just go up to the 8th minute and you'll be good. The rest of it is just
Let me see if you can hear something.
Yeah, I can hear.
Perfect.
A little soft.
Yeah, it's getting
engineering that generally deals with the study and application of electricity, electronics, and electromagnetism. Electrical engineering has now subdivided into a wide range of subfields, including electronics, digital computers, power engineering, telecommunications, control systems, radio frequency engineering, signal processing, instrumentation, and microelectronics. Many of these subdisciplines overlap and also overlap with other engineering branches, spanning a huge number of specializations such as hardware engineering, power electronics, electromagnetics and waves, microwave engineering, nanotechnology, electrochemistry, renewable energies, mechatronics, electrical material science, and more. Electrical engineering is one of the newer branches of engineering, date back to the late 19th century. Early experiments with electricity included primitive batteries and static charges. However, the actual design, construction, and manufacturing of useful devices and systems began with the implementation of Michael Faraday's law of induction, which essentially states that the voltage in a circuit is proportional to the rate of change in the magnetic field through the circuit. This law applies to the basic principles of the electric generator, the electric motor, and the transformer. The advent of the modern age is marked by the introduction of electricity to homes, businesses, and industry, all of which were made possible by electrical engineers. What do electrical engineers do? Electrical engineers work in a very wide range of industries, and the skills required are likewise variable. They apply the physics and mathematics of electricity, electronics, and electromagnetism to both large and small scale systems to process information and transmit energy. To do this, electrical engineers design computers, electronic devices, communication systems, test equipment, electric power networks, and improve systems through problem-solving techniques. The tools and equipment that an individual engineer may need are similarly variable, ranging from a simple voltmeter to a top-end analyzer to sophisticated design and manufacturing software. The job duties of electrical engineers depend on the industry they are in, but could include carrying out feasibility studies for new technical developments, drawing up project plans and circuit diagrams using computer-assisted engineering and design software, estimating costs and project timings, coordinating the work of technicians and craftspeople, testing installations and systems and analyzing test data, making sure projects meet safety regulations, overseeing inspection and maintenance programs, attending meetings, writing reports, and giving presentations. They usually work on projects with other professionals like civil engineers, architects, and engineering technicians. Skills required in electrical engineering. 1. Circuit designing. 2. Instrumentation and electrical measurements. 3. Power transmission and transmission lines fundamentals. 4. Electrical drives and electrical machinery. 5. Power electronics. 6. Renewable energy fundamentals. 7. Microcontrollers and programming languages. 8. Presentation and communication skills. 9. Fundamentals of electrical power generation and maintenance of electrical power plants. 10. Control systems and control machinery. 11. Quality control analysis. How much money electrical engineers make? According to the U.S. Bureau of Labor Statistics, electrical engineers earn a median salary of $93,000 per year. Salaries typically start from $59,240 and go up to $146,820. Top 10% of electrical engineers earn a monthly salary of $10,972 or more. In addition, electrical engineers with a master's degree or professional license improve their attractiveness to employers and may qualify for higher wages. The average engineer with a master's degree in any field earns approximately $900 more per month than one with a bachelor's degree. Electrical engineers usually work around 40 hours a week. They may have to work occasional overtime to meet deadlines. They could be based in an office, factory, production plant, workshop, power station, or research facility. Top companies hiring for electrical engineers. The Boeing Company, Lockheed & Martin Corporation, International Business Machines Corporation, also known as IBM, Google, Apple, General Electric, and BMW Group. Pros and cons of being an electrical engineer. Pros: high salaries, wide range of career opportunities, job flexibility. Cons: risky occupation, workload can be unpredictable, competitive atmosphere for promotion. However, the advantages of a career in electrical engineering can certainly overcome the disadvantages for someone interested in the field. Future progression. According to the U.S. Bureau of Labor Statistics, employment of electrical and electronics engineers is projected to grow by 4% between now and 2022. The rapid pace of technological innovation and development will likely drive demand for electrical and electronics engineers in research and development, an area in which engineering expertise will be needed to develop distribution systems related to new technologies.
I think that's about it, Conrad.
Perfect.
Yeah, it's pretty close to end. Yeah, good enough. Yeah. Now, we could have a discussion exactly if anybody would like to.
Yes. So
Perfect.
so if you have any questions, guys, do raise your hand on the panel and on the WebEx panel, and Conrad will unmute you if you want to use voice and audio. So feel free to put your mic put your video on as well. And while you guys, if you have, so while we wait for questions, I have a second question. Is there anyone here? Any hands raised? Conrad, can you check and let me know?
Not yet. I think the people are
Okay.
a bit shy.
Yeah. All right. So the second question is, so you worked for Mott MacDonald, right?
Yes, I did. Yes.
So I assume that is kind of a consultancy
It
job.
is.
So what is the life of a consultant look like? So
Oh,
you start,
yeah.
you
Very good.
start the, just so that people will understand the different options they
Sure,
have and how
sure,
life
sure.
looks like. You start the
Yeah.
day at 8 a.m. and let's see.
Let me tell you, as an engineer, especially in electrical engineering, electrical power engineering, you could be a utility engineer or work for a manufacturer like an ABB, GE, or Siemens, or Schweitzer, or you could be a consultant that actually helps support some of those functionalities. The difference in, for example, in the consulting world is you get to work in your spread of varied, complex, and challenging projects. As a young person in my career, starting off in the utility helped me out a lot because it helped me get my feet wet in understanding what this business was all about. And then, when I finally, I actually went back for an MBA after my PhD and after working 5 years. So this was the advent of what the California energy crisis in late 1990s, and then the Enron crisis. So I didn't understand the business side of it that I needed to learn, and about energy markets and how does the open market work. So I went back to do that. But the consulting world helped me get into various challenging projects from EVs to autonomous technology to energy storage to offshore wind design and wind implementation, fax devices, other forms of energy conversion. So it gave me a broader experience in doing that. But consulting career is a career that can be very quick-paced, and sometimes, even though, remember, sometimes wealth does not equal total happiness. So, be careful about, okay, I've got all this wealth, but I'm totally stressed out and I'm not happy, versus taking a little less and doing fruitful work, and you enjoy your colleagues and actually rising organically in your organization is a better approach. Or you might want to consider doing that when you have a more stable life and you feel like traveling or doing something, then that fits out well into that type of environment. But it's a very good question, Sala. Yep, absolutely.
Perfect. Thank you. We have one question from Roy. I will mute him so he can just make the question with the voice. Okay, Roy?
Hi, Conrad. Can you hear me?
Okay. Yes, I can hear you.
Okay. Thank you, Dr. Mukherjee. And Conrad, I feel proud that I find Dr. Mukherjee here again. I had the opportunity to meet him. I think it was 2018 in IEEE IPC, Rural Electric Power Conference.
Yeah.
And that was the first introduction with him. And today I've enjoyed the conversation and everything, the presentation, everything nice. That's a funny question, and I think later we have to focus on this thing. Day after day, we are running towards the reliable power supply. That means we are now using quantum computing and lots of GPS devices, and that means the accuracy, the maintaining the power for not for a single millisecond. Okay, so the next world will be led by the electrical engineer with the conventional electricity, or we have to focus on more on the storage devices? That's my question. Okay, to make the reliable power.
Yeah, no, it's
Thank you,
very,
Dr.
very
tricky question.
Oh, it's a very good question. It's a very good question. Very, very good question. Let me tell you, reliability is a concern for the electric grid, but a bigger concern around the world is resiliency. And resiliency, when I say resiliency, I'm talking about high consequence, low probability events, such as a polar vortex, extreme weather conditions, a cyber attack, those are considered to be resilience events and to stretch the grid to actually solve those problems as we retire out our resource capacity, such as coal plants and the natural gas uh, availability changes. Um, Storage is going to become a very critical player, but storage is not just battery. For example, pumped storage hydro,
Yeah.
that is a hydro plant, is storage.
Yes.
So it could have, they're trying to make it less capital intensive to build it more to help the grid. So broadened technical thinking and applied research is going to be needed to moving to what you just said. And it's going to become more and more relevant, especially for dispersed generation and microgrids. And, people are building houses where your home has become a generator. So your home literally contributes to grid inertia. Why? So, for example, many people in Texas put out the heat in their house through the F-150 12-volt onboard charger on their truck. The truck was lighting up the house. The same thing with having a Tesla in your garage. A battery pack can actually charge or light up your home. A certain amount of load can be taken. Or putting up solar to charge a Tesla Powerwall in your garage that helps light up your house during the day, and then doing off-grid applications. So that's going to become more and more relevant. And that's the new generation. That's not my generation. Mine was the old classical format, because that's the new world that you're talking about. So you're right. Absolutely. Great question.
Thank you.
You're welcome.
Perfect. We have another question in the chat. It's from Alton. How to find opportunities in power engineering approach graduation, and how to know which area you would fit best?
Very, very good question. I wish I had more career planning advice, but here's what I would do is I would get to events like this. First thing is to talk to peers, talk to colleagues, understand what do you want to do with your life? Do you want to start your career as a utility power engineer? Or do you enjoy working on devices and products? So if you know utility, then you can actually apply to an investor-owned utility, a government utility, a municipal, a co-op. There are tons of them. If I go to the Edison EEI.org, you would actually see all of them listed out there, and any open jobs that are out there you could apply. But if you prefer to work, let's say, with instrumentation, with sensors, you want to go to a product developer, you enjoy relaying and protection and control, you might want to consider working for a Siemens or a Schweitzer or a Schneider or an ABB. That is on the other side of that actually interfaces with the grid utility engineer. But now further, if you enjoy challenging projects of a mix, I would consider going in as a consultant, or even broader, if you enjoy applied research, I would consider research institutions like my federal lab and other places. We have engineers at our lab, and they do super work tied back with advanced transportation. They're looking at wireless power transfer. They're looking at magnetic levitation. They're looking at other things that you enjoy that will be at some point commercially applied. So that is where you would consider a variety of opportunities. And the world, it's not just the United States, it's global opportunities. So be a global engineer. It's needed all over.
Perfect. Thank you very much. We have another question here in the Q&A. This is really interesting. Why do recruiting agents ask for experience if those they are looking for entry level? Or we tell them we are a new graduate person?
Mhm. That is a big, you need somebody to open the door. Same thing happened with me 30 years back. And that is a big problem. But disappointment is a stepping stone to success. So here's the couple of career recommendations. This is, I have grown age, college age children. My oldest son is in medical school. My younger one is a Air Force cadet. So I tell them a couple of things with career. Number one, as an engineer, you're already well established and well positioned. You are not at risk at any time in your life because you've chosen a path that is always and always will be in demand. It's not a music degree where you have to struggle to find something, okay? So it's a real degree that has value. And if you add a master's or PhD, it's even more valuable or become more licensed. It becomes more and more valuable. So you're going to need perseverance in your first job. And what you do is you position yourself by saying that I'm not going to chase wealth, let wealth chase me. So use that. So do I enjoy an entrepreneurial spirit? Do I want to join a company that's very flat and entrepreneurial, and some consulting firms are like that? Do I enjoy working with a group of people that are like-minded and can convey that kind of message? And a rejection or several rejections is a stepping stone to success. It will happen. What you need to be is persistent. What you need to do is touch base with people, talk and discuss, and start your process early. When you go for your interviews, learn about the company, learn about their income statement, learn about their revenue structure, learn about what their product is about, and how are they organizationally structured. Don't just go blank and do it. And when you do a resume, don't make it more than a page. You can bring it up later on and make yourself boring. Keep it interesting for discussion. And always have integrity and truth. If you cannot do something, an entry-level job, the kids that say, I don't know that, I don't know, I don't have any experience, are the ones that are willing to learn. People want to see that you're coming in and are willing to learn and grow. But if you come in and saying that I know it all, Mr. Know It All, and you're just an entry level, people are going to figure you out in seconds. And so say what you know, and what you don't know, it's okay, and you're willing to learn.
Perfect. Thank you very much. We have a question from Laura. I'm just going to mute her and she can assign the question. Perfect. All right, Laura.
Yes, good afternoon.
Good afternoon, Laura.
Thank you, doctors, to be here with us today. So, question is, what do you think about the female representation in this field?
Awesome.
And how experiences been working with women in electrical engineering, if you have done it? Thank you.
Well, what a wonderful question. It is something that it's close to my heart. We need women engineers. We need women electrical power engineers. Laura, the women electrical power engineers that I've worked with in my career and still do are incredible. We need diversity. We need women engineers because we're losing out on what I call the brighter half of our GDP. Why? Because women are super bright, they're super organized, and they're super understanding and organized to how things are. And I see the future with STEM education, especially with women in engineering, is big. We're going to need electrical and energy science engineers for the Mars Perseverance going to Mars. We are going to, because we need diverse thinking, and we need innovation, and we need work flexibility. Just because you're a mom, it doesn't mean that you cannot have a career. What COVID has taught us is that you do not need to come to an office to get something done. You can work from anywhere and be equally successful. You You can get mentored over a computer and do it. So being transparent and being open is always available. It's no longer the industrial age of working from 8 to 5. If you're comfortable working at 3 o'clock in the morning, good for you. Young people enjoy that. They, just be professional in communicating that to your peers. Remember, the career advice that I always give young people is you don't have to impress your supervisor, your manager, your vice president. They are meaningless. The people that you have to really get conducive with is your peers. Get their confidence so that you can back them up and they can back you up. Then they know, because they are the ones who will promote your saying, yeah, Laura can get this done. And then you'll get more challenges coming your way. So working collaboratively, not demeaning anybody, working with integrity, encouraging diversity and broader thinking, and having women in your organization is so critical. That question, Laura asked that question in interviews. How many women engineers do you have? Ask it straight out. If it's not diverse, that's not a company you want to be with. Ask them how many women engineers do they have on the board.
Okay.
If it's just a bunch of old men, you don't want to be there. They don't have open thinking. So you want to have, innovative, broader, smarter thinking. Great question, Laura. You're going to be highly successful in life.
Thank you.
Of course.
Perfect. Thank you. We have another question in the Q&A. Just let me read here. Does the Oak Ridge National Laboratory has any internship this year?
Yes. So Oak Ridge does have internships. It's through the ORISE program. It's called ORISE, which goes through the Department of Energy. The broadened one-on-one internships are also available, but it has slowed a little because of COVID. So, but the ORIS program and then some other ones which I could post along, it's called the SULI program, SULI. The SULI internship programs are available for all the national labs. And I encourage you to apply. I encourage you to consider it. And the other thing that I want to tell young engineers or who are just still in school is don't feel disappointed at grades. Grades are just a metric. It's your learning process. It's okay if you flunked a class, just take it again. And yeah, because nobody in the workforce is going to ask you what your GPA is. Nobody's going to care. Okay. It's just a mild stepping stone to doing what it is. If you aced it, good for you. But if you did not succeed and didn't learn, then that's a problem. You need to retake it and learn it. That makes you a better engineer. So it's a long run. Life is a marathon, not a sprint.
All right, perfect. Yeah, I can see Zirgua with like the hands on. So I don't know if not make a question.
Can you unmute him or her?
Yeah, is unmuted.
Yeah.
Hello?
Can you hear me now?
Yes, I can hear you. Yeah, perfect.
Thank you for answering for the first question. My second question is like, what is the current challenge for foreign electrical engineers who studied in US, like to find any power distribution related areas?
Very, very good. They are challenges, but I'll tell you this. The United States needs STEM majors and engineers. They need people of science background. If we are to succeed as a nation, whether it be the US or Canada, we need engineers. In what I call the visa process, or what they call, I think STEMs get an additional 3 years on their OPT, I believe, right? Another 3 years. And in all probability, you get, most companies will sponsor you for actually getting what you need to succeed. The challenge is you may not initially get what you want. but you can use that as a learning process to step into the newer direction and position yourself as a global engineer. So if it is to solve a problem in Guatemala, why not? You can always come back to the United States. If it is to solve a problem elsewhere, why not? You can use that when you're young as a learning um, tool to get better in whatever you want to do, and in being successful. Here's what I tell young engineers always, is that when you're assigned something, when you enter a work organization, remember, if you haven't rolled your sleeves up, right, and you're just being an empty drum at a meeting, talking big, but you're not doing enough of the value add work, it eventually catches up with you. People are going to figure it out, and it'll happen quicker than you think. So roll your sleeves up, get involved, and be the first to raise your hand on projects that even might sound difficult, but you'll figure it out because you're an engineer. So that's what we're trained for. We're trained to think like that. So projects, I don't know anything about it because I didn't learn in school. No, don't worry about it. You'll figure it out. You'll get it done. It'll happen. You just have to have faith in yourself.
Thank you very much. I really appreciate it.
You're most welcome. Most welcome.
Perfect. We have another question in the Q&A from Kahan. How should we make ourselves the best candidate for jobs, internships? Any guidance?
So, for jobs and internships, number one, when you get a job offer or internship offer, have your 10-minute elevator speech ready. Okay. Do a due diligence on the company or organization that you're going to interview with. Know their financial structure, know their product, know a little bit about their organization. So when they say, do you have any questions for us? If I say, I don't have any questions, that shows no interest or want. Try to show that you have, you can add value because you love this job, or you're thinking of, this is what I want to do with my life. And be honest with it. If they ask you something that, have you done Python XYZ or whatever, I don't know. I mean, I'm no computer programmer, and you say, hey, I've dabbled in it, but I have a working knowledge. I'm no expert. But, undersell yourself rather than oversell yourself. So that is one way you can position yourself. Same thing with your resume. Be truthful and be authentic. Don't oversell yourself. Don't claim to be a project manager and I can see you just graduated from college on LinkedIn, because I can spot that a mile away. Okay, so it's like when I used to tell my kids, hey, you got an A in your advanced placement statistics class, but the national exam you got a 1 or 2. That's a discrepancy that a graduate admissions officer would spot a mile away. So people can spot these things. So don't be a fake, just present who you are, and your credibility should carry you through. And if you get a no, so what? It's not the only game in town. It's a million jobs over there, and the economy is going to be booming in the next 5 years, especially in energy and data science. These are two unique areas.
Perfect. Thank you very much. I have one personal question.
Sure.
So basically, we know the opportunities just appear like for who is prepared, right? But I'd like to know about you. Like, you have an extensive background, but these opportunities just appear for you, or are you looking for them? Did you have a mentor or some people to guide
I
you?
did have a mentor. Yeah, exactly. So most of the opportunities after my first job, this is what happened to me. Once I completed 4 or 5 years, the other thing that I would encourage people to do is be careful about changing too many jobs. So show a pattern that you've established yourself 3 to 5 years. If you change a job, too many job changes reflects poorly on your resume. So don't do that, because you don't build capital or credibility. And when they say, give me 3 recommendations, you give your favorite people, oh, my friend, this, and this. Guess what? Those are not the people they're going to call. They're going to call your old company and your old professor and find out exactly who you are. So that's what they're going to do. So you need to build capital. Don't burn bridges, even if you hate an organization. Leave professionally. What I would say, Conrad, is, in my case, after 4 to 5 years, I got bored with what I was doing. And therefore, I wanted to explore myself. So I opened myself to people saying that, what opportunity do you have? I'd consider it. And they would go, oh, we have an opening. Would you consider that? I said, yeah, oh, send me a CV. And boom, I'd send it and get it. And that's how it turned for me. So once I did something, especially in power engineering, you can do generation, you can do transmission, you can do renewables, you can do distributed generation, you can do controls, you can do reeling and protection, you can do. It's to learn each area and apply it, because if you niche yourself once, you put yourself at risk. So, because what happens in the world, as we know, is we're under economic conditions. Sometimes we're under glorious economic conditions, and sometimes when the demand goes down, that goes right away. So you want to protect yourself. That's why having an engineering degree protects you. Having a master's or a PhD protects you even more, or an MBA protects you even more, because you have that. Making a PE protects you. It's an insurance against that. So it's like taking risk away. That's what it does. And
Perfect. Thank you very much. I think we can go for the last question we have in the Q&A, just to close the session. And the question is, which states have more power distribution and generation related jobs? Currently, are companies, currently hiring new graduates?
That's a great question. Okay, I am very familiar with the Southeast. So I could tell you, like, for example, Sala's University, Clemson, Georgia Tech, the states of Georgia. Here in North Carolina, we have many, many opportunities with EPRI, ABB, Siemens, Schneider. We have research organizations that tie back up in Tennessee. The broader thing is you could look at other applications too, such as you don't have to go into grid applications. You could go into even companies such as Boeing, such as Lockheed Martin, and Northrop Grumman's gone, but you could look at defense contractors that need power engineering. Navy research and has a lot of electrical power engineering work that's being done. So there might be opportunities there. Then there's opportunities for big time in renewables. So wind and solar manufacturers, developers, and implementers, they are, so many young companies are coming out right now. It's beyond, I can't even name them. They are like, every day there's 2 or 3 new ones. So even if it's a smaller organization, which is not name brand, that's fine. That's how you build credibility. You'll actually rise higher in a small organization as you build and grow with the team. So those are ways to look at it. Don't just grab the first thing that comes around and, oh, this much amount of money and, oh, I'm good. Think it out. Yeah, and correlate the work to the value of money, because money will come. It's you don't want the rise is as fall as the rise is as fall as the as hard as the fall. So if you rise too quickly, by the time you hit 30, if everything is done, then the next 30 years you're going to be struggling to find yourself to go up, and you're going to fall. So take your time. It's okay. Learn it, and you're going to grow, and you'll be fine.
Perfect. Thank you very much. Really interesting questions and also the answers. So with that, we close our session. I want to thank you, Dr. Srijib, for share a little bit of your experience. I'm sure that all these advice and tips are really useful for all the students and young professionals. also for your time and partnership to encourage us with our podcasts. We have been developing each month one podcast just to bring a new tip or a new suggestion for the students, and they can learn with like a high level professionals to have a good career and good professional life. Thank you very much for your time.
Yeah, absolutely. Well, I'd like to say thank you to you, future Dr. Conrad, and thank you, future Dr. Sala, for this and for what you guys have bright futures and everybody here does. Don't hesitate to contact me if I can help guide you or help you get to a point of contact that you might like to wish or like to choose. Um, there were people that helped me in my career. I'm in the latter end of my own career. So I'd like to help others. And if I can, all I ask for is honesty and integrity and being authentic. That's all I care about. And just make the world better. And women engineers, dope. I mean, thumbs up, men and women, of course, but women, we need them.